Welcome to the webinar 3D Printing Applications in Restorative Dentistry. The lecture is being presented by Dr. Adam J. Kennedy, DMD, FAGD, and we are going to begin shortly. And now it is my distinct honor to introduce Adam J. Kennedy, DMD, FAGD. Dr. Kennedy is the program director for the general practice residency at Yale New Haven Hospital. He earned his DMD from Case Western Reserve University. After completing a general practice residency at the University of Washington, he began practicing in Bellevue and returned to UW as an affiliate instructor in 2017. Dr. Kennedy is a past president of the Seattle King County Dental Society. And now it is my pleasure to say, take it away, Dr. Kennedy.
Thank you so much, Jessica. I really appreciate the warm introduction. Thank you to NDX Labs for hosting tonight's session, and I'm just so excited to be here. So tonight, as Jessica mentioned, we'll be talking about 3D printing applications in restorative dentistry. Now, I do have quite a bit of material to get through. You'll know and probably notice as we go along that really any of these topics can be broken out into an hour session in all of itself. So happy to answer any questions. We'll hold them for the end, but just put them in the chat and we will get to it once we wrap things up. But again, I'm so excited to get started. So who am I and why am I here talking about this? So just quickly, briefly, I am a general dentist. I had a private practice in Bellevue, Washington for many years. My wife and I relocated to Connecticut. We have 2 young boys and they keep us busy, and her family's from here, so we know it all takes a village. I'm currently the program director at the Yale New Haven Hospital GPR, training residents, and it's something that I'm just very passionate about. I also really enjoy getting into technology. Digital dentistry has been a complete game changer for all of us. I took a course with MIT Professional Education a few years ago on machine learning, and so I know I've got a course coming up in a couple weeks here with NDX as well about that. So stay tuned for more info on that. Quick disclosure here, I've got no financial or commercial interest in any of the companies that we'll talk about in tonight's presentation. This presentation is not or does not constitute an endorsement of any specific vendor or system, nor does it imply that one vendor system is inherently superior to another for any particular task or application. I have received an honorarium for tonight's presentation from NDX. So tonight's objectives, we're going to look at and explore the utilization of 3D printing technology in restorative dentistry. We're going to discuss the process of designing and fabricating dental restorations using these printers, and we'll talk about some of the challenges and limitations of this technology in our clinical and lab settings. So why 3D printing? Why are we even talking about this at all? I like to really think about business aspects. Many of us are business owners. Some of us work, for maybe a DSO or other organizations. And I don't like to really mix healthcare and business, but that's the reality of the world that we live in. Every year, Dental Economics and the Levin Group put together an annual practice survey. I'm excited because it usually comes out in May, so we're just a few months away. So this is from last year's data set. But we look at this polling here, and what are the top challenges that are facing our dental practice? And again, I know we're waiting for 2025. I would imagine a lot of this is probably going to ring true, though, for this upcoming survey. Number 1, rising overhead. We can all relate to that. Ability to hire clinical staff comes in closely at number 2, declining insurance reimbursements. And this list goes on. And so why am I talking about this at all? Can we look at technology to help kind of bridge this gap to really help with the rising overhead? Can it do some of the things that maybe our clinical staff currently do or help make their jobs a little bit easier, streamlined? Insurance reimbursements is a whole different thing and it's in its own right. And we can touch briefly on that when we talk about AI, because that's certainly gaining popularity in that realm. But I just want to bring that up. So when they look at this survey here, what are the top 6 answers that they're doing to address that number 2, that current staffing challenges? And I really want to highlight number 4 here, which is adding technology for productivity enhancement. So again, it's going to be that practice efficiency, practice production, and then giving staff members or team members more time to focus on other things. So again, let's kind of frame tonight's discussion, if we can, about how can this really the implementation in a technology like this really boost our productivity, make our team members, certainly have a little bit more time throughout the day to focus on other things that may be more critical. I'd like you to maybe close your eyes and think about a piece of technology in your life that really changed the way that you move in this world. For me, this was back in, I want to say 2007, when we got the late, great Steve Jobs introducing the iPhone. And so, obviously it's something that this type of technology, I would imagine, is in everyone's pockets nowadays. But we didn't really see, perhaps, maybe many of us probably didn't see perhaps how this would really expand and explode different applications. And it's really an incredible piece of technology that we use every day, just about. Not just the iPhone, Android, and other competitors certainly have great products as well. But to me, this was a pretty monumental aspect in my life when I had my first iPhone. And why do I think that that's important to relate to this at all? For dentistry, the thing that's similar to that moment for me is a digital scanner. So I picked mine up just a few years of getting out of dental school. In 2017, I picked up the 3Shape Trios, and it was just a game changer. And it's come a long way in the past decade as well. So again, we can see these applications growing and growing with new and modern materials. The material science in dentistry is just really exploded and expanded, and we'll touch on that tonight as well. So this isn't a math lecture at all, but we think about the current ways that we manufacture dental restorations. The predominant one is the subtractive method. And what do I mean by that? We think of subtractive milling. Some of you may have milling units in your office. You can do quite a bit with them. The limitations with them are the cost. It's quite expensive to, invest in the milling unit. We've got maintenance and upkeep. We've got these burrs and drills and things like that we've got to maintain. The nice thing with these is it's pretty quick. You can use just about any material. This is a zirconia block from Cyric that we're looking at right now. And you get great definitive restorations right in your office for same-day restorative dentistry. So pretty incredible technology that's certainly blossomed over the past 10, 20 years. Now, conversely, we also have additive manufacturing, and this is what we're going to touch base on tonight. So this is a great diagram. This is the Formlabs printer, but many of them are similar in their mechanism. So I just used this because I thought they had a really good diagram to explain this. The main things that we're looking at is we've got on the bottom here, in their instance, a set of LEDs. And then we've got this resin tank, and it holds resin. And then we've got a build platform at the top that just kind of dunks, and I'll show you a video on this. And then that LED flashes a picture, and it cures that resin in the resin tank. And over time, it adds up. That additive manufacturing builds essentially the restoration that we want to make. So when we look at this is from 2024. So all of this data that you'll see tonight, and I encourage you to check these QR codes because it'll take you right to these articles here in their entirety. All this data is going to be in these research articles that I talk about tonight are within the past few years because this is a very new technology. So this is a great one just to give you some of the basics. So I've highlighted just some aspects that I felt were important to discuss tonight. When we look at 3D printing in general, you can see the early years were 2000s. We had the digital light processing or DLP. And again, that we'll talk about in just a minute here, but ultimately it uses a light projector to cure that resin layer. And then we just stack, add to build our prosthesis. Then a few years later, we developed stereolithography or SLA. We've ultimately got a UV laser that selectively solidifies the resin layer by layer. So similar process, but the laser is going to trace that prosthesis kind of from start to finish like a maze, and it goes layer by layer and builds that up. Now, things have changed quite a bit, but things have improved, as you can imagine, over the past 20, 25 years. And the technology is really exploding lately. And so we'll talk briefly again about some of this here. So DLP, as I mentioned, if you look at the number one, that's the projector. It's going to shoot an image into a mirror, and it's going to cure layers in the resin tank. Number 5 is the build platform that's going to drop in, cures it, lifts up, resin gets cleared away, and then down again, cures another layer, and just builds it over time. SLA or stereolithography is the same kind of deal, but we've got a laser that's going to just trace it. So it takes a little bit more time than just flashing an image up. So what are some of the advantages and disadvantages? Again, the two predominant ones on the market right now are SLA type or DLP using LEDs. So that's kind of what I wanted to focus on. But you can see in this chart here that we've got a lot of other different types of 3D technologies. We've got selective laser sintering, SLS, selective laser melting. So this is neat because you can print metals. So it's something to be thinking about. And I think we'll see more and more of this as time moves on. And again, you've got other different ways, but when we think about it, DLP typically a little bit faster than SLA. So digital light processing is faster than SLA, but it's pretty marginal, really. It's gotten to be pretty close in and how quickly they can produce these types of things. So what is the next big thing in dentistry? I just put this up here. This is one of the predominant makers here, Sprint Ray, I'm sorry, put this up. But again, we know this is a very important thing that's really changing our practice, and it's pretty neat to see. And some of you may already have 3D printers in your practice, which is pretty cool. So what do? We capture data. I liken it back to that iPhone where we have this device, and what can we do with it? Well, we've got that digital scanner. What can we do with it? We can send it to a milling unit and do subtractive manufacturing. We could send it to a 3D printer and do additive manufacturing. Each has their pros and cons. The nice thing, and I think a lot of people have gotten into this, is because this is pretty cost effective. Many of us have a digital scanner already. These units are anywhere between, $7,500 to it can go as much as $60,000 or $70,000 if you want a full, like, floor to ceiling carbon lab type printer. But it depends on what you're trying to print in your office and what the needs are of your practice. So again, we can scan, we capture the data, we take it to our in-house, or we send it to the lab and the lab designs it. We print it in our office, or the lab is going to be printing it in the lab, like NDX, and then we deliver it to our patients. So what are some of the things that we'll discuss tonight? What are we using this currently for? I'm fortunate in my practice to have a 3D printer, and I'll discuss and show you a couple things that we're using it for. A good close friend of mine and colleague uses it quite routinely for more advanced things, so I'll share some of his work with his permission. So dental models, surgical guides, occlusal guards, digital dentures, which is really kind of that up and coming thing that we're seeing a lot of these labs, NDX included, moving toward clear aligners. Ortho, I think, has really set the game off here with how they've utilized this technology in their office and doing batch printing of trays and sequences to do in-house clear aligners. You can do provisionals and wax ups, indirect bonding trays for orthos, and even crown and bridge, which is so exciting. So what's the workflow here? Put this slide up because I think it's really critical, and I'm not here to say that one product is better than the other, but the point being is for 3Shape in particular, there's a very specific way that we need to scan. And so if you look at the lower arch, you want to start on the occlusal. You do the kind of squiggles there, which is a rotation buccal to lingual to capture. Then you do the lingual, and then you scan the buccal or facial. For the maxilla, it's a little bit different. We're starting with the occlusal. We do a little bit of rocking in the anterior segment, and then we do buccal, and then come back around with the lingual. So what I'm saying is it's really important to know the type of scanner that you have. There are very specific techniques, so I implore you to take a look at the manufacturer's instructions on how to do the scanning, because it really does impact how the quality of your digital scan ends up being, which is the basis and foundation for the print ultimately. So this is an example of, we've got our scan, what happens next? So we create an STL file, which is that stereolithography. It's just the way that we save the file type. And we drag that file, if we're talking about digital models in particular, into some type of software. Now, this is just the Formlab software where we can go ahead and print the models. You can use ExoCAD, you can use SprintRay's program to do this. There are a lot of different ways to do this, but ultimately, I'm just trying to give you the idea of the concept here. We scanned the patient, we converted that file to an STL, and we're bringing it into some sort of design platform. Now, in this one in particular, you can click on this little tooth button here, and it goes through a wizard that shows, okay, well, here's how you create the base. First, we got to rotate the model so the occlusal surface is pointing up. Then we're going to go ahead and trim the model a little bit. We're going to add a couple millimeters. They're using 2 millimeters here as a base height, and then hit OK. And then you can either print it directly on the build platform, which is shown on the right-hand side of your screen. So you can see that they probably use about 3 millimeters here. These are just some models from our office. Or you can print it on what they call a raft and use supports. This uses a little bit more resin, takes a little bit more time to do. There's a little bit more trimming that you'll need to do. But this is if you just kind of go back to this screen and hit auto design. Generally, it's going to just put it this way for you. So, the pros and cons of This is faster when it's printed directly on the build platform, uses less resin, so it costs a little bit less, although again, kind of pennies on the dollar, so I'm not too concerned about that. The one caveat with the one when it's printed directly on the build platform is it's pretty hard to get off the build platform. Some of the newer build platforms are flexible metal, so you can kind of pop these things off and you don't have to worry about damaging or breaking the resin cast. Some more traditional ones are not flexible and you've got to kind of scrape them off with a spatula. I will say the one when it's printed on a raft, you can see how it's got rounded edges, are much more straightforward to get off the build platform if you're not using a newer build platform that's flexible. So I just wanted to show a video here just briefly. I think it just solidifies the idea that we've got this LED in the bottom, build platforms coming down. There's a little resin arm that just kind of keeps the resin moving and flowing. And as you'll see here, the build platform will sink all the way down, and then it'll snap a quick photo in just a second. And then it'll raise up again. The resin arm will move and kind of keep the resin flowing so it's not all curing, and then the build platform will go down. So again, you can see it goes down all the way, and it cures, and then it raises. So what happens next? So now we've got our final printed resin model here. We put it in a wash. So usually we use about 97% isopropyl alcohol. They have wash stations, as you can see here. So you can take this and go ahead and just put it in this bath, this tray here, turn it on, and it'll drop it in this isopropyl alcohol bath. It's going to kind of mix things up a little bit. It's just a way to clean that resin. It gets a little sticky if you don't use this, and it just kind of cleans that model up really nicely. Now with 3D printed models, we want to cure them. And so after that, all these companies have their own curing stations. So you can see that we just put it in there. It almost is like a triad curing unit, but it's specific to 3D printing. So you can see I got this set for 10 minutes. You can change the heat. And with that, each material is a little bit different. This is where I would refer you to the manufacturer's instructions. This is just specific to Formlabs because that's the one that we have in our office here. So we use a lot of draft V2 resin. It's just version 2, and draft is just kind of a quick and easy one that you can print at about 50 microns. It's great for orthodontic appliances, suck downs, really just the general models that we are using is perfect in draft resin. It's just a little bit faster than using something like model resin, which is a little bit higher in their quality. And then you've got things like the dental surgical guides and permanent crowns. And you can just see here that the timing for the cure settings is a little bit different, right? We've got 5 minutes for draft V2, 5 minutes for the model V3. For the surgical guide, it's a 30-minute cure time at 60 degrees Celsius. And the permanent crowns about 20 minutes at 60 degrees. So again, each material type, the point here is to just confirm with the manufacturer's instructions that you're going to cure it at the right time and at the right temperature, because it does vary based on the type of resin that you're using. So is this any good? You may be thinking, alginate, it's pretty inexpensive, and I've got just stone in my office that I've had for 30 years and a big bucket of it, and I just keep buying it because it's pretty inexpensive. Is this worth it? Is it as good? Is it as true? Is it precise? So this is an article from 2022 in the BDJ Open, and you can see how they compare the trueness and precision of different 3D printers that are used in dentistry. So they took a look at 12 different ones. So these are the list of 12s. They've got Formlabs on there. They've got some of the other ones there. All of these vary in the technology that they use. We were talking about DLP and SLA. We're moving towards like an LCD or LED based DLP or SLA, which is kind of the newer thing since this article was published in 2022. But these all vary in price and the technology that they use. How did they study this? Well, they had a test cube, which we're looking at here. It's 30 millimeters. There's an X, Y, and a Z plane. And so they took this, they printed it, and then they scanned it again and overlaid it to see if there was any difference, right? And so what did they find? I don't have the time to go through all these articles tonight, but if you do have any questions about them, I'm happy to get you that additional information. And as I mentioned, those QR codes will take you right to this article. But the conclusion is that the current range, and this is again just a few years ago, the current range of these 3D printers can produce clinically acceptable levels of accuracy. They show that there's no statistical difference in the results of some of the budget printers and the more expensive printers. This study confirmed that all 12 of the 3D printers can reproduce a reliable, reproducible model. Printing of dental arches and restorations is more challenging in terms of complex and fine details, and it deserves further investigation. So again, there are a lot of different types of 3D printers out there for things like model making. You could probably get away with some of the budget ones and be just fine. What I will say is just a cautionary tale, and this is just my take on it, is that, I'd be really remiss to use something that doesn't have like FDA clearance on the types of resin if you're going to be using it in a patient. And what I mean by that is if you look at a lot of the things like surgical guides, which is even temporarily used in a patient, we'll say, but conversely, something like a definitive crown, which some people are using. We want to make sure that these are coming from reputable sources and you're not just using kind of a budget resin because it's less expensive. Want to make sure that it's gone through the studies to make sure that that's a viable option for patient use. So what are some of the other things that we're doing? Occlusal guards. So here's a picture of one that, again, my colleague and close friend, Dr. Rob Appel, down in Texas, he sent my way. And you can see it's a resin-based occlusal guard. He printed on his printer. Looks pretty standard and fit the patient beautifully. So how do we design things? Again, there's so many different types of design platforms out there. Many of them come with the printer, but if you really want to get into CAD design, the kind of top one I would say is ExoCAD, although it's quite expensive. But you see other companies like Plan Mecca, they've got their own design suite. You've got Trios and 3Shape has their own design suite. So you've seen a lot more of that coming out there. Blue Sky Bio is another one that's free where you can do some CAD design. But where does the lab come in? I'm admittedly not someone who likes to be the lab technician, nor do I have the time necessarily in my schedule to do these kinds of things. So you can take your digital preparation, you do the preparation, you do your scan, or you get the digital scan. You can either design it yourself or send it to NDX or another lab to have it designed for you. They can either send that design file, that STL file back to you to print it or mill it, or they can print it and mill it themselves, and then they send it back to you for insertion. So you can do it a couple different ways. We've had cases where we do the design ourselves and then send that out for printing, or we have it designed by our lab and they send it to us and we print it in-house and then deliver it to the patient. So a couple of different ways to do this. This is an example of ExoCAD, their design software for doing night guards. I know this is a little funky, the way that they have the anatomy really dialed in on this lower guard. And then the other thing, as I mentioned, if you're sending it to the lab or using the design software, AI has really taken off for some of the more straightforward, I'll say, tasks. So this is from, Sprintway, as I mentioned down here, and we've got AI design where within a 5-minute turnaround, you can submit the scans and get a printable design, which is pretty quick. Or they can do a signature design, which likely starts with some of the AI, and then it's tailored by one of their team members that can go ahead and kind of custom design it as needed and then send that back to you. So that takes about a day. So again, as I mentioned before, do you want to design it yourself through one of these softwares? Do you want to have AI design it through some of the software that's built in? Do you want to have a lab technician design it and send it back to you, or have them print it at their lab and just send you the final? So a lot of different ways to do these things. So what are the mechanical properties of these types of guards? So is this something that a 3D printed or resin-based occlusal guard is going to withstand the forces that many of our patients, especially the ones that need an occlusal guard, are going to be putting on it? So this study looks specifically at a couple of different ones that are out there. Dental LT Clear is the one that's from Form Labs, just to give you an idea. Ivoclar has, the traditional pro-base cold, which is PMMA. You got the ProArt CAD splint, which is also PMMA, but that's milled. And then you've got the splint that's 3D printed with acrylic light polymerizing resin, which is the other material that we're looking at here tonight. So when you look at this graph, we're looking at flexural strength, which is extremely important in this type of appliance. And you can see that the ProArt CAD splint, which is the one, if we go back for a second, is the milled PMMA, ends up having the greatest or highest flexural strength in megapascals. So that one takes the cake. And I think many of us may know this already, that milled or pre-polymerized PMMA is actually the strongest way to have PMMA. Now, the more conventional ways, like pro-base cold, which is conventional PMMA, is pretty strong too, but it's not as strong as that pre-polymerized PMMA. When we look at the A and AB and B, this just shows that groups like A and AB are not statistically different. A, B, and B are not statistically different, and then C and C are not statistically different. So you can see that, the milled PMMA is holding up best. The conventional PMA is right there with it, although slightly lower in its flexural strength. And then you've got our resin-based dental LT clear and some of the things like ortho rigid that hold up pretty well as well. If we look at Vickers hardness, again, same kind of thing. The ProArt CAD splint is at the top. Shortly or slightly below there, and the Vickers hardness is the Pro-Base Cold, which is a more conventional approach for PMMA. And then we jump into the resin-based types. So the conclusions here are that this is all in vitro, and that's the one caveat tonight, is this research is all fresh, and we haven't really had an opportunity to do some really robust studies, randomized control trials, et cetera, with these materials in our patients or out in the real world yet. So I do have to admit that I take a lot of this with a grain of salt. This is all benchtop studies at this point, but still important to be looking at here. So again, the findings of this one in particular showed that the milled occlusal splint materials have the highest mechanical properties, the flexural strength and surface hardness, in comparison to cold polymerized or the additively manufactured, which is the 3D printed materials. So I think that's the takeaway there. When we look at conventional acrylic, CAD/CAM, or 3D printed occlusal splints, again, I just want to emphasize this is just another study that showed that, hey, we took a couple of different types. We've got acrylic splints, we've got 3D printed samples, and we've got the milled splints, as you can see here. We put them on the benchtop. We, pretty much just pound into them as long as we can until they either break or not and see what they can withstand. And then we look at the deviation here. So you can see that milled splint has the highest coefficient here, that the mean is 3,000 newtons, which is pretty strong. When we look at acrylic splint here versus the milled splint, much lower. Your flex print splint here, the Night Guard flex resin, is pretty high, and our resin splint is not far off there. So you can see the milled is going to have the best qualities in this type of appliance. So when we look again, it was concluded that the milled splints were the most resistant to fracture. Printed splints, the splints fabricated with flexible rigid resin, definitely and adequately withstood the applied forces. And so they were saying that this material can be recommended as a viable option for using this. So that to me is the takeaway. Are we quite there yet with these studies that are out with patients using this in the real world, so to speak? Not yet, but certainly all the benchtop studies suggest that 3D printed occlusal guards are just fine for patients to utilize. What I'll say with that, having used both types, we've had patients that will break a milled PMMA splint. For that patient, I wouldn't say, oh, well, let's make you a new one and let's use it, use resin for that. I would be really reluctant to do that, as we know it's not going to maybe hold up this much. So, be mindful. This is all patient specific to, the case and the use. But if you're looking for the strongest material, milled PMMA is going to be there. But we know that, resin-based splints are certainly appropriate for many patients and can withstand those applied forces just fine. So 3D printed dentures, where do we go from here? This is a real exciting and hot topic, and I can probably spend another hour just talking about this, this one topic here. So what are the benefits of 3D digital dentures? Certainly it's a lower cost production. The materials and the hardware are a lot less expensive. Even, the milling units versus an additive material like a 3D printer is a lot different. That they're accurate, consistent, we get high quality results. The neat thing about this is that if you're doing like an immediate, for example, immediate denture, you can scan the patient's teeth if they're in fair shape, which I mean, sometimes they're not, and that's why they're ending up in a denture. But if they've got generally the rough anatomy there, you can use that anatomy and then print them in resin and use that for them. So it is truly custom teeth that are specific to the patient. Now, again, you can use your traditional denture teeth, or you can just kind of use the design software to use whatever type of teeth that you want to add to it, which is just fine too. But I thought that was a pretty neat way to think about it. And then the nicest part is when you have a digital denture, the way that this works is, there's no more my dog ate my denture, or I left my denture on a tray and I threw it in the garbage and I totally forgot about it, or I left it in a hotel room on a cruise or something. You've heard it all, I'm sure. But, the fast remakes aspect of this is really quite incredible. So once you get things digitally designed, you can just go ahead and print another one or mill another one. And that's a really nice aspect. One thing I do want to mention, which is kind of funny, and I'm sure many of you can relate, my previous practice in Washington, I had two storage units in my building in the basement level that were just filled because I had purchased a practice from another doc who had been in that office for many years. So two storage units completely filled floor to ceiling with models and old charts and things that we just had to keep. We have to keep those things for at least 7 years. And I think they just kind of stay in there because what are we going to do with the boxes of models and things like that? The nice thing with digital technology that I think about often is, you don't have to really have all that stored on a hard drive or in the cloud or not in two storage units that you're paying for. So that's one more thing that I'd like to to mention about digital tech here and digital scanning. So this is a great article from Dr. Pam Marigliano Muniz. She's in Salem, Mass. She's from Tufts University. Put this together a few years back. It's from the ACP, which is American College of Prosthodontists, and it's just a great overview of the workflow. And so we're just going to talk briefly about that because I think this is pretty critical. Now, this is, again, some years old and we've really dialed it in. They're showing that they're going to manufacture it with a subtractive method and using pre-polymerized PMMA. But even so, it's just nice to go over some of the techniques here. So you can scan the patient's edentulous arch. We'll talk a little bit about scanning in another future webinar. And I'll give you some tips on how to do that because there's a couple of things that you need to be mindful of when scanning these types of arches that are edentulous. Then you either have a centric tray or some way to capture the centric relation, right? So that's visit one. Then you can go ahead and design it. So the lab can design it for you. If you have design software like Exocad in your office, you can go ahead and design it there. Then you can print, which is the nice thing, a resin mock-up. This is a monolithic resin. They're just not, you just look at it right in the middle there. It's just white. Doesn't need to really look great. This is kind of the wax try-in phase, right? Does this look good? Sure. You can also go ahead and take a functional impression here, do your border molding with your, if you're going to use light body or heavy body rather, to do your border molding, if you're using green stick compound, however you want to do it. Use these as custom trays. You know that you've got the teeth set up right, the midline looks good, everything's happy. You get your bite and centric relation, send that back to the lab, or you can scan it in your office. And if things are looking good there, then you just go ahead and send that to the milling unit or the printing unit. And so that's the technique here. And you can see we do a lot of removable in the clinic that I work at in a residency program. It's really nice to take what was once 5 or 6 visits to get a denture from start to finish down to 3 or 4. Definitely saves you on the chair time. Patients are pretty impressed with the way that things work here. So it's just a nice addition to the workflow and certainly expedites the treatment time. Now, the really neat thing is that the patient comes in already with a denture. Well, you can go ahead and take their existing denture, assuming that they're relatively happy with it. And then you're already kind of at step 2 here, right? You've got the try-in here. So you can use that as a custom tray for a functional impression there. Send that to the lab or you can scan it yourself. I recommend sending these to the lab as long as the patient's okay with not having their denture, which they may not be. If they aren't, then you might scan it in your office. But having this information sent to the lab in some capacity, whether you're sending the denture or scanning it yourself, and then they go ahead and just make any design modifications if they need to, and then they can print it or mail it, and then the patient's got it. So in theory, 2 visits if you're doing someone that already has a reference denture or an existing denture to a new denture. And the nice thing, as I mentioned before, is once they're happy, let's say patient's just thrilled with how this one looks, you've got the digital file there. So, hey, I lost this, or I broke it, or I dropped it and a truck ran over it, or whatever the crazy things that you hear in your office every day. It's one of those things that, okay, no harm, no foul, Mrs. Smith. We'll get you another one printed or milled and have it here for you. And this is what the fee's going to be. So again, here's something where we can look at this workflow again. This is, let's say, an immediate denture. So the previous one was someone had a denture already. This is immediate. You can take alginate impressions or a scan. We do our digital design, extract the teeth, and then deliver that immediate denture here. And they're showing what I'll talk about in just a second here, pretty neat thing that's changed in the way that we mill on these PMMA pucks. They have different colors ultimately. You've got the pink for the soft tissue, and you've got the white for the hard tissue here, which is pretty slick. And then again, this just really takes it home with the digital denture workflow. Let's say patient comes in, they don't have a denture, they've been a dentureless for years, just never got around to making a denture or lost it and never came back to have one made. You take your prelim impressions or you do a digital scan and the centric tray. You can use Gothic arc tracing or this face bow here. You take your functional impression after you've got things printed there on that resin base, or they can use, again, the PMMA base if you wanted to do it that way, but the resin is a lot less expensive and more affordable. And then you go ahead and have that designed, and then you do the printing or manufacturing, however you want to do it, and deliver that final restoration. As I was just talking about here, this is an example just from Ivoclar. They've got these dual colored discs now, so pre-polymerized discs where you can go ahead and print the soft tissue, or I'm sorry, mill the soft tissue and the hard tissue in one monolithic unit. Before it used to be kind of two, where we'd have the denture base and then the teeth, and we'd put them together. And so that is actually how it works with 3D resin. Now, there are some newer printers out there, not typically any that I've seen, at least for in-office use, that can do two different colored resins in the same resin tank. But this is how we do it. You print the denture base in the type of denture base resin, you print the teeth in the teeth resin, and then you go ahead and cement them or lute them together. So here's an in vitro study again of shear stress from CAD milled versus printed denture base resins with bonded denture teeth. And so this is how they designed the study. They took a central incisor and they put that bonded denture tooth into different types of resin bases. They had a control group, with the Lucitone PMMA. They had a test group, which is a CAD, which is a milled PMMA, which is the IvoBase 2, number 2 right there. And then they had the test group, which is a Polydent, more conventional PMMA, Formlabs base resin, and then the carbon Lucitone digital print. So when we look at this here, the HPL 199 is kind of the control group there, that standard PMMA. The PD is the Polydent PMMA. And then you can see the IB CAD, which is the IvoBase CAD PMMA, lands right here. So again, the control is pretty in line with the other PMMA, and then the CAD, interestingly, in this study showed it was a little bit less strong, or able to withstand shear stress here. And then you've got your Formlabs, which isn't far off from here, and then you've got this CLD, which is the carbon Lucitone digital print. So you can see, again, is this a reasonable study? I think it does show some important details and information on the shear stress, but is it really practical for denture wearers? And you might be able to argue for or against that. So conclusions here: the bond stress of a denture tooth to heat process and milled denture base resins was significantly better than that of 3D printed denture resins. So printed resins are photopolymerized and could be weaker inherently than these pre-polymerized milled PMMA pucks. Obviously, there are differences in the printer resolution, variation in curing wavelengths could explain why these printed resin groups were statistically different than each other. But generally, for complete denture wearers, this is a nice takeaway here. All resin materials used in the study may be clinically acceptable, as the shear stress for all groups was higher than the reported maximum biting force of complete denture patients. So the takeaway here is, yeah, we know that maybe the printed resins aren't as strong or able to withstand the shear forces as some of our more traditional methods, heat process in particular. But for complete denture wearers, where they don't have a ton of great strength and they're probably not putting a ton of shear forces on these dentures, it's acceptable for this type of use in a clinical standpoint. So let's take a look at another study here. We've got clinical outcomes of milled, 3D printed, and conventional complete dentures in these patients. And this is a nice systematic review from early 2024, the ACP. And again, I implore you to look into this. I don't have the time tonight to go in depth of each one of these studies here, but the takeaway here is that improved retention and reduced production time were found in both milled and printed fabricated dentures, which again, I think is kind of the future here. I know NDX has some great solutions with that too, as do many labs. patient perceptions and satisfaction are independent of the digital or conventional manufacturing. When we looked, and I don't have any studies here tonight, but from what my lit review here on this stuff, over time, there was a really good study where they looked just 30, 60, 90 of patient quality of life and their self-reported happiness on their denture and quality of life with CAM fabricated dentures and conventional dentures. And what they found is that over time, both of those dentures ended up being at the same level. So not statistically different, usually after about 90 days. But again, here you can see we know that improved retention and reduced production time are going to be found with these milled and printed units. Perceptions are really independent of digital or conventional manufacturing, and we just want to see more studies really of this kind of thing in the future to really make sure that we know we're going in the right direction. So I think the most exciting thing about this is we can print crowns, right, and provisionals. Is this crown gonna be able to withstand the force as a milled crown? And I think that's something to be thinking about when we're doing this. Is this something we can use as a definitive crown? And hopefully in the next 10 or so minutes, we'll have an answer for you on that. So why am I talking about boring CDT codes at 7:45 on a Tuesday night? That's a great question. But the reality is that the ADA changed their CD code definition for porcelain ceramic, where they removed a little bit of it. And so it currently reads that it refers to materials containing predominantly inorganic refractory compounds, which are porcelains, glasses, ceramics, and glass ceramics. So now we can think about, does this material that we're printing or milling, does it predominantly contain inorganic refractory compounds? And if so, that would, in theory, follow under this definition for porcelain ceramic. So when we think about this, here is a top competitor's printed crown. So they have resin. All of this stuff is resin because it gets cured, but it has ceramic aspects or these inorganic fillers that now have a content of these fillers exceeding 50% by mass. So by definition, it does qualify as a porcelain ceramic crown. So it's just something to be mindful of. So again, these boring CDT codes keep coming back again. So a 2710 is a resin crown, right? So indirect resin crown. 2740, you may know, is a porcelain ceramic crown. These two codes have very different prices associated or price tags associated with them. Now, I can't sit here and talk about pricing too much or they're going to come after me, but generally you would imagine that the 2740 is a more expensive crown from a patient standpoint. So if the definition is true and the chemical composition of these printed resin crowns, or some of them, exceed 50% by mass, in theory, you could bill out a 2740 for that. Now, I called the ADA on this because as an ADA member, you do have resources and someone who works in a department that will talk to you about these CDT codes and get you the information. And I just asked, hey, I'm a dentist and I'm printing resin-based crowns that have a filler content of 50% or more ceramic impregnated or ceramic filled resin crown. What code can I use? Am I interpreting this the right way? What are other dentists that are calling in using? And I was shocked to hear that many are using the 2740. Now, again, I'm not advocating for this. I'm just sharing that information. I would be a little reluctant to do that as I don't think we truly know yet how long these crowns are going to last because they haven't been tested in the mouth in our patients long enough to be using it definitively, in my opinion. But it's just something I did want to share that if you do call the ADA and ask, they may say that the 2740, by definition, if you're using material that has greater than 50% of that ceramic impregnated in the resin, you're okay. So let's talk about some of these crowns. There are a lot of different ones on the market. Bego is from Germany. They've got a crown that Formlab uses. It's called the permanent crown resin. You can see just some of the ideal measurements here, like the flexural strength and the flexural modulus post-cured. So 116 megapascals and the modulus is 4,000 plus, right? So pretty impressive strength there. Not as strong as like an Emax or zirconia, where the flexural strength of an Emax, as an example, is anywhere between like 350 to 500. Zirconia is stronger at about 600 to 1200. So definitely not as strong as a flexural strength, even post-cured from these crowns, but reasonable to be used in a patient's mouth if needed. Here's another ceramic crown. This is the Sprint Ray ceramic crown. You can see that their flexural strength at 150, their flexural modulus a little bit higher here at 7,800. When we look at the Vario Smile Crown Plus, which is one that I'm going to show you a case study with here, you can see again flexural strength varies between 116 and 150. Just to give you an idea, the hardness there is a 90 short. Vario Smile Trinique, which is a newer one that just hit the market. You can see that the flexural strength is 120 megapascals and the surface hardness is about 90. So they're all roughly the same. You'll see though that the Sprint Ray ceramic crown has the strongest or highest flexural strength. So here's a case from, again, my close friend and buddy, Dr. Rob Appel, down in Texas at Humble Dentistry. This is a patient, younger patient that came in, 20-something-year-old with gross caries on number 19. And you may think, hey, I've got a milling unit here. I can print an Emacs for this in my office in 15 minutes and go ahead and move forward with a definitive crown. I didn't need to worry about 2710s and 2740s and calling the ADA. Who's got time for that? Well, you may be right. But let's say this patient here, we'll call him John, doesn't have the finances to afford that 2740 crown. What can we do that's maybe a step up from a PMMA and just something that may be a little bit more definitive for them as they work to maybe find that money or can come back in a few years and get that definitive crown or just see how this one lasts because we know that the marginal integrity is pretty solid. So this is what it looks like clinically. Some, again, gross caries there on the buccal. This is what it looks like cleaned out. I love the use of a rubber dam. Go Rob. I do want to just stop here and just talk briefly about some of the reductions, at least from what the manufacturer is saying is what we need to have on the shoulder, the type of width, the shoulder width, lingual reduction and sizal edge. Pretty standard for many of the crowns that we're doing, at least with the zirconia or Emacs. About 0.5 in the incisal and the occlusal in the posterior, you want about 1 millimeter, and the lingual reduction 1 millimeter in the anterior and posterior as well, and incisal edge about 1 millimeter there. So you can see just the rough design there. What I'll say with this is my preference, and it's based on the literature as well, that a rounded shoulder is going to be the best type of preparation design circumferentially, which sounds a little wacky there, but a rounded shoulder is going to be able to be scanned the best. So we've looked at studies and you can see that in the literature that a rounded shoulder just gets captured the best on digital scanning. Some people prefer the chamfer for Emacs and everything, and that's fine too, but it's just something to be noted that your scanner is going to pick up a rounded shoulder best. So here's Dr. Appel's beautiful prep here. It looks gorgeous. He's got a build up there with Rebuilda. And then he designed it and printed it in his office and used some staining and glazing to get you there. But I mean, when I look at this picture here, gorgeous picture, really hard to tell the type of material. I wouldn't think that this is a 3D printed, resin ceramic crown. And you can see there, that's what the intaglio looks like. I do want to talk briefly about just how we cement this. Again, I always refer to manufacturer instructions. There's many different crown types out there. Some are using VarioLink. This one in particular wanted to use Panavia V5. Again, important to note, here are the cementation protocols for Panavia. Generally we have either an alumina powder to blast it and then ultrasonic clean and dry, or you can use like an etchant with hydrofluoric acid for lithium disilicate. Each material is going to be a little bit different, so I do implore you to just read the manufacturer's instruction on that. You'll apply a ceramic primer, you'll put a tooth primer on there, let it sit for 20 seconds and dry, and then you'll put the Panavia in there. You can either tack cure or just wipe some away with a small brush, and then keep that isolation for about 3 minutes. This is what the restoration looks like in the mouth here. Number 19, gorgeous, right? Here's another view of that there from the buccal. And here's the radiograph, which I think is even prettier. It just looks so nice. He did fantastic work. So way to go, Dr. Appel. So let's look at this. Marginal adaptation and fracture resistance of milled and 3D printed CAD/CAM hybrid dental crown materials, various occlusal thickness. That is a mouthful, but it is a really important paper here out of the Journal of Prosthodontic Research. So they looked at different types there. So we've got that Vario Smile from Bego, as I mentioned, from Germany there. We've got milling, so you've got the Sarah Smart and Vita Dynamics, and then they looked at the different cements. Many of us are probably using, Unisem or Rely Excluding Plus, but this is what they looked at in this study in particular. Clinical significance here is these CAD/CAM hybrids can be an alternative, minimally invasive treatment that can provide good marginal adaptation and acceptable fracture resistance. They've been shown to be favorable for clinical situations with limited occlusal space. We might have severe tooth attrition, short clinical crown. These resin bonded with a thin occlusal veneer restoration of hybrid dental materials is suggested in the case of unnecessary tooth removal. These 3D printing techniques provide superior marginal adaptation over the milling ones. This is a little shaky, I'll admit, but in this article, the research suggests that that is the case. And then we know that the advantages of 3D printing are its low cost and less waste in the fabrication process. The mechanical properties still need improvement to be comparable to those of other hybrid materials. So when we think about conventional, digital, again, many of us are using technologies that have changed dramatically in the past decade in our practice. But does digitizing this journey really enhance the patient perspective? And so this is just a quick op-ed ultimately from that same doc, Pam Marigliana Muniz, who's also the chief editor of Dental Economics. And really, we just want to be thinking about if we're going to really take this on in our office, we want to make sure that it does truly create efficiencies. And so again, I take us back to that original article from Dental Economics, that survey that Levin Group puts out with them from last year. Is this really going to help make our practice more efficient? Certainly our team can be overloaded, Lord knows, with short staff and just the way that things have been going in the wake of COVID. It's a different practice. So can these technologies really improve that? Is the team bought into this? I mean, some of you may say, hey, I'm ready to go buy that 3D printer right now. And yeah, I'd say, sure, there are definitely ways to make it work in your office. But you want to make sure that the team is bought in on it too. Does it offer any new services, right? Is this something that, yeah, I can see how maybe printing my own occlusal guards instead of milling them is best. Or if I don't have a milling unit, maybe I start with a 3D printer. There are a lot of different ways that it might fit your needs here. And then I'd definitely say create a plan. Let's onboard the team, let's train them, let's talk it up to patients, maybe send out a newsletter where we say, hey, Dr. So-and-so's office, we've just introduced this cool technology and can't wait to show it to you when you're in our practice next for your next hygiene visit. I do want to kind of close here with this systematic review here and a meta-analysis. Journal of Prosthetic Dentistry, JPD, is a really renowned research mag, we'll say. And this really, to me, is a great summary of this. So we have 3D printed prosthetic materials. We've got milling materials, which we know are tried and true for many years. And then we've got conventional processing, which is starting to seem a little outdated, but still has its use. So I won't go too hard on that. But they looked at a lot of different printing techniques. Some of these, the SLS, the SLM we talked about briefly in the beginning of this discussion. They looked at different types of ceramics, zirconia, lithium disilicate, different polymers like PEEK and PMMA, different metals like cobalt, chromium, titanium, etc. And again, not to go into in detail, but the conclusions here that a substantial similarity was found in the mechanical properties of this machine milling or the subtracted milling type and the additive milling. So 3D printing and milling have substantial similarities in the mechanical properties, which is a sign of the reliability of this technology. Milling seems to present better results only in relation to the flexural strength and flexural strength after aging. So if we looked at this, a meta-analysis, they're taking all the lit, they're looking at it, what fits the criteria. The flexural strength here, we found no significant difference in this article. We saw an increase here. We saw an increase in the flexural strength in 3D printing versus milled. In these articles here, a reduction was reported there. What I'm trying to get at with this slide is that still, the research is varied. Many of this, if not all of it right now, from what I can tell, is all benchtop in vitro studies. So I do want to see more of the scientific basis before going all in on this type of tech. But it's been very promising. And so the takeaway here, if there's one point to go home with or go to bed with tonight, the clinical implications here. To date, 3D printing materials appear to be suitable for interim and removable prostheses with similar properties to the milling techniques. However, studies with long-term follow-up are needed before the extended use of these printed restorations could be recommended. So hopefully, if you've been paying attention, I know it's a ton of information to throw at you all at once like this, but we've talked about how we can use this 3D printing in our practice, the process of designing and fabricating, and then some of the limitations in this current technology. So thank you all for your time tonight. It's been an absolute pleasure talking to you all and being able to discuss this clearly. It's something that I really look forward to going into work every day and kind of not playing around with this stuff, but playing around with this stuff in my office. This QR code just goes to my LinkedIn. I'd love to connect, and I'm excited to answer any questions you may have.
Thank you, Dr. Kennedy. Wow. Well, I'm floored. But we do have a couple questions here really quick. How do you see integration of the technology improving patient outcomes in restorative dentistry?
Yeah, I mean, I think some of the big things we think about is it's a pretty affordable technology to get into our practices. And so, where we look at milling units that are 60,000 plus, some of them are over $100,000 to get that milling unit for under 10K or around 10K, you can get a 3D printer and use it for your patients. And it's quick and easy and do same day type restorations or a day turnaround, in your office if you'd like. So I think certainly there's a speed factor, a cost-effective factor too. Maybe you don't have to bill as much. I know, God, how can I ever say that? But maybe you have a more economic type of restoration that you can offer your patients that you may not currently be offering. So there's a couple of different ways that we can improve patient outcomes with these technologies.
Thank you. And then this next question, it came in a little while back before the latter slides you showed, so they probably got their answer, but how long do you think 3D printed teeth last?
Hard to say. Again, all the studies right now are in vitro benchtop studies. And so it's showing promise that these things will last pretty long. There have been some studies specifically with resin dentures versus the PMMA. And we know that resin typically doesn't hold on as long as the milled PMMA. It just wears out faster. But we know we can replace these if we've done a digital design pretty quickly. So let's say it only lasts for 2 or 3, maybe 4 years of a resin printed denture. Well, maybe you have it worked out where your fee is a little bit different, where we can just print another one for that patient at a reduced cost and get them moving again. Or conversely, you can just send it to a milling unit or have your lab like NDX go ahead and print it for you, or mill it for you rather in a pre-polymerized PMMA block. So I don't have that answer right now, unfortunately. It's showing promise that it lasts pretty well and pretty long, but I'd love to see some of the data before I spoke confidently on that.